Till now, we have studied what is meant by black body, what is meant by black body radiation spectrum, and the experimental results obtained by Lummer and Princeton. Now, we have to study the theoretical explanation of black body radiation spectrum, and actually this is a failure of classical mechanics, where classical mechanics fails to explain the black body radiation spectrum. So first attempt to explain the black body radiation spectrum was made by scientist Wien. So first we discuss the Wien's law. Alright. So scientist Wien used the theory of classical thermodynamics, and by using the theory of classical thermodynamics, Wien derived a formula. Wien derived a formula to explain the black body radiation spectrum, and that formula is emissive power E lambda in the wavelength range lambda and lambda plus d lambda, means interval of wavelength will be d lambda, is equal to C1 upon lambda raised to power 5 into exponent of minus C2 upon lambda t into d lambda, and this is a Wien's formula which was derived by scientist Wien. Now, by using this formula, here it is observed that as the lambda increases, then here lambda, which is present in my exponential term, as lambda increases, then E lambda also increases. So as lambda increases, E lambda, that is emissive power, also increases, and it should increase continuously. Means as lambda goes on increasing, then emissive power should go on increasing continuously. But it is known to us, we have already studied from the black body radiation spectrum, that initially as wavelength increases, emissive power increases, becomes maximum at a particular wavelength, and later on it goes on decreasing. So Wien's law explain result in shorter wavelength region only, not in a longer wavelength region. Means complete black body radiation spectrum cannot be explained by the Wien's formula, and that's why another attempt was made by scientists Rayleigh and Jean, and that is called as Rayleigh-Jean's law. So to derive their formula, they use again the classical laws. By using classical laws or classical theory, Rayleigh and Jean again derive a formula, and Rayleigh-Jean's formula gives the energy density in the wavelength interval d lambda, that is emissive power E lambda into d lambda, is equal to 8 pi kT upon lambda raised to power 4. Here in Wien's formula, C1 and C2, these are the constants. while lambda is the wavelength, T is the absolute temperature. Similarly here, K is the Boltzmann constant, T is the absolute temperature, and lambda is the wavelength into d lambda. So this is a Rayleigh-Jean's formula, and now by using this Rayleigh-Jean's formula we can explain the blackbody radiation spectrum. But from this formula it is observed that as lambda increases, then E lambda decreases, because it is inversely proportional to the fourth power of a wavelength. So as lambda increases, E lambda decreases, or in other words we can say that as lambda decreases, then E lambda increases, and it increases continuously. It should increase continuously. Again, from the blackbody radiation spectrum it is clear that as the wavelength is longer, then the emissive power will be smaller. But as wavelength decreases from longer wavelength side, E lambda increases. But it is true up to certain wavelength. But if we further decrease the wavelength, then emissive power E lambda goes on decreasing. It does not continuously increasing. So to explain this one, I will draw a blackbody radiation spectrum here. Only one curve, which is a graph between lambda and E lambda. Blackbody radiation spectrum, graph between wavelength and emissive power. And this is a curve corresponding to one temperature at a particular temperature, suppose capital T. Now, from this curve, what Rayleigh-Jean's law suggests, as the lambda decreases, emissive power should go on continuously increasing. But this is not true, and hence we can say that Rayleigh-Jean's law explains the blackbody radiation spectrum only in longer wavelength region, but not in a shorter wavelength region. So here I will draw the curves corresponding to Wien's law as well as the Rayleigh-Jean's law. So according to Wien's law, as wavelength increases, then emissive power should go on continuously increasing. This is Wien's law, or this curve represents the Wien's law. Means it is true for the shorter wavelength region, but fails to explain blackbody radiation spectrum in longer wavelength region. Now, if we use the Rayleigh-Jean's law, then according to Rayleigh-Jean's formula, as the lambda decreases, then this emissive power should go on increasing like this. So this curve represents the Rayleigh-Jean's law. Second curve represents the Rayleigh-Jean's law. And here it is observed that this curve is valid only for the longer wavelength region, but not in a shorter wavelength region. Hence, the complete blackbody radiation spectrum cannot be explained by the Wien's law as well as the Rayleigh-Jean's law, and hence classical physics fails to explain the blackbody radiation spectrum, because we have seen that both the laws, Wien's law as well as Rayleigh-Jean's law, both laws are derived by using the classical theory, and both laws fail to explain the complete black body radiation spectrum, and this is a failure of classical physics to explain the black body radiation spectrum. Alright. Now, from this Rayleigh-Jean's law, which is valid in a longer wavelength region only, and it fails to explain black body radiation spectrum in a shorter wavelength region. So, shorter wavelength region means it corresponds to ultraviolet or X-rays or gamma rays. So, for smaller wavelength region or shorter wavelength region, Rayleigh-Jean's law fails, and this failure is also called as the ultraviolet catastrophe. This is also called as the ultraviolet catastrophe. That is the limitation of a classical physics to explain the black body radiation spectrum in a shorter wavelength region.